Injection molding introduction. Injection molding process is a manufacturing process used for producing discrete parts such as bucket, bumper, chair, electrical switches, toothbrush, home appliances, ball pens, fittings, etc. from thermoplastics polymers. This process involves melting of plastic raw materials by heating and plasticizing in barrel and screw, and then the melt formed is injected under pressure into closed mold and cooled. Cooling melt takes the shape of the mold cavity and you will get molded part. Injection molding process. Plastic material is fed into the heated barrel, mixed and melted, then injected with high pressure into the mold cavity, where it cools and solidifies, and then ejected. This is very widely used, since this is the only process by which one can form plastic parts with complicated geometry. Machinery and equipment used are plastics injection molding machines, auxiliary equipments such as material feeding systems and dryers, mold cooling or heater system, scrap grinders. Molds. Operating cycle of injection molding machine. Let us understand the molding cycle. Mold closing. In this function, moving platen moves forward to close two halves of the mold. Mold closing is bifurcated in two phases: fast close and mold safety. In mold safety phase, speed and pressure is reduced to avoid collision of two mold halves. Tonnage. After the mold halves touch, force is applied to avoid mold opening during high pressure injection. This tonnage is maintained until the injection sequence and cooling is completed. Injection. Once the tonnage is built, nozzle comes forward and nozzle contact force gets developed. Then molten plastic is injected into mold cavity. Injection phase has been divided into two stages. 1. Fill. 2. Pack and hold. Fill stage. During the fill stage, the material is pushed into the cavity with required speed depending on the type of product. Pack and hold. The pack and hold stage ensures that the material injected into the mold remains under controlled forces till the gate of the product is solidified and the material does not flow back. Cooling. The injected material should be allowed to sufficiently cool before it is ejected. Refilling. During refilling, the screw is rotated by hydraulic motor and plastic granules driven forward through screw flights. Plastic granules are softened by external heat and melted by shearing in screw flights. For better plasticizing and homogeneity of plastic melt, back pressure is to be applied. The screw speed can be controlled depending upon the type of material used and temperatures set during refilling. Mold opening. During mold opening, first tonnage is decompressed and moving platen moves back to open mold halves for part removal. Ejection. The mold part is pushed out from the mold by the ejector mechanism. Injection molding machine comprises four major sub-assemblies: clamp unit, injection unit, powering system, control unit. Let us look at the clamp unit. Function of clamp unit: houses the mold, provides mold movement, counters injection force by applying clamping force, opens mold, houses ejector assembly. Clamp unit comes in three different design concepts: direct hydraulic, monotoggle, 4-point toggle, 5-point toggle, hydromechanical. Now we are reviewing construction of toggle clamp unit and its components. Stationary or fixed platen. The stationary platen holds one half of the mold. Moving platen. The moving platen provides an area for mounting the other half of the mold. It moves back and forth to open and close the mold. Die or mold height adjust platen. This platen is used to adjust the clamp assembly to accommodate different molds of various thickness and to adjust tonnage. Hydraulic ejector mechanism. The ejector mechanism is used to eject parts from the mold after the cooling is completed. The back and forth movement of the center ejector rod causes the ejector pins in the mold to move back and forth to part ejection. Tie bars. All three clamp platens are tied with 4 tie bars. The tie bars are used for guiding machine platens and for holding clamp system together to generate clamping force. Tie bars sustain the clamping force during tonnage. Normally, all tie bars are supposed to take equal load. Toggle mechanism. The toggle mechanism holds the moving platen and the die height adjust platen together. It is a mechanism for the movement of the moving platen and holding the mold in under stretch condition during tonnage. Crosshead. The crosshead is the mechanical link or coupling between the clamp cylinder and the toggle mechanism. At mold touch position, clamping force is applied on crosshead, which straightens the toggle links and maintain toggle straightness. Mold height adjustment mechanism. This mechanism is used for movement of die height platen to adjust different mold heights. Hydromotor drives the die height nuts by chain or sun wheel gear system. Now we are reviewing concept of direct hydraulic clamp. Major components of direct hydraulic clamp unit. Ram. This is a part of the main clamping cylinder which creates clamping force. The oil column behind the ram is pressurized to create the desired clamping force. Traverse cylinders. These cylinders are used for movement of moving platen. Closing and opening takes place by pull and push of the traverse cylinders. Pre-fill valve. Pre-fill valve is used for filling the oil from tank to clamp cylinder. Tonnage build activities after pre-fill valve is closed. Let us look into another design of clamp unit known as two-platen or hydromechanical clamp. Two-platen hydromechanical clamp is advanced version of hydraulic clamp unit. It is a combination of mechanical and hydraulic clamping. The main features of this mechanism described as smaller footprint designed for serviceability, reduced footprint by an average of 15%. It is unique two-platen technology. Benefits are high-speed clamp, fast and accurate, centralized tonnage. Robust split lock design, central acting ram, short stroke ram and direct even clamp force helps in reducing tonnage build time, evenly distributed clamp force, zero platen deflection, improved part quality and reduce mold wear. Let us understand the injection unit construction and its functions. Feeding of plastic material into barrel. Plasticizing and conveying plastic material. To inject plastic material with high pressure in the mold. Generates contact force to prevent material leakage from nozzle. Major components of injection unit. Barrel. The barrel houses the injection screw. Barrel stores the melted material until it is injected into the mold. Heaters and thermocouples. Ceramic band heaters are fitted on the barrel, which provides the heating to the plastic materials, which is being conveyed by the screw. The actual temperature of the barrel is sensed by the thermocouples fitted on the barrel. Feed screw. Screw performs following two functions. Plasticizing. The injection feed screw rotates through driving motor and screw geometry. It helps to melt material from the hopper down into the front of the barrel. Melted material moves forward by conveying actions of screw flights. After desired volume is accumulated in the barrel, screw stops. Injection. During injection, feed screw acts as plunger. It pushes the accumulated melted material into the mold through nozzle. Feed screw is normally divided in three zones: feed, compression, or transition and metering zone. Slider set or tip, seat and valve. Slider set fits in front of the screw. It is having three parts: tip, seat and valve. It acts like a check valve. It allows the material to pass through during the refilling, but will not allow it to flow back during injection. Barrel adapter. Barrel adapter fits on the barrel. It is having a conical shape inside. It passes melt from barrel to nozzle. Nozzle. Nozzle fits on the barrel end. It directs the melt into mold sprue bush. Hopper. The hopper holds the raw material. Hopper mounts on the barrel to feed the material to barrel. Feed throat platen. Feed throat platen holds the barrel. Hopper assembly and injection cylinder are anchored on it. It contains a pathway that allows material from the hopper to feed down into the barrel. Injection cylinders. These cylinders are used to move the injection platen forward and backward, which in turn moves the injection screw forward and backward. Two different types of injection cylinders are used: integral and external. Extruder motor. This is a hydraulic or electric motor which rotates feed screw during refilling cycle. Powering unit. Electrical energy is converted to mechanical energy through hydraulics. Induction motor or servo motor is used as prime mover, which is coupled to hydraulic pump. Pump delivers oil flow in the system. Vane pumps, gear pumps, axial piston pumps are used in injection molding machines. Types of powering unit. Entire machine uses powering system which can be fully hydraulic, electric, combination of both hydraulic and electric, which is termed as hybrid. Major components of hydraulic system. Pressure relief valves are used to limit the pressure at specific limit. Flow control valves are used to control the speed of actuators, example cylinders, hydromotors. Directional control valves are used to direct oil to the actuators. Cylinders are used for linear movements, example clamp open or close, injection forward or retract. Hydromotors for rotary movements, example screw rotation, mold height adjustment. Control unit. Microprocessor-based programmable process control is used for coordinating functions of clamp, injection, and hydraulic system. It synchronizes the hydraulic or electrical powering systems and mechanical systems for smooth movement. All the settings can be done from controller, which makes the job easy for the operator. Mold setup time is less because mold data can be stored and recalled for future use. Let us review control parameter settings. Clamp setup. Clamp setup is very important for injection molding machine. We can set clamp open or close positions and speed, mold protect face position and speed, clamping force. Injection setup. By this page, we can set the parameter in injection molding machine for cooling time, fill time, pack and hold time, short size, screw speed, etc. Temperature setup. We can set temperature as per requirement in this page to melt the material. Keypad is used to perform different functions and to enter the parameter values. Startup process. Switch on barrel heating and wait till the temperature is achieved. After all of the zones have gone through the proper soak time, hopper can be opened and the screw rotation can be initiated. Soak time is important for uniform distribution of heat throughout the barrel for safe working of slider set and screw. Initial screw speed should not exceed 15 to 20 rpm so as not to damage the screw or barrel. During this time, when the screw is recharging, no one should be standing near nozzle. As the screws start to refill, the motor load will gradually increase. This is an indication that material is feeding. Once a steady flow of polymer exits from the nozzle, the screw speed can be increased to the desired operating RPM. Machine is ready for operation. Shutdown process. Close the hopper slide and stop the flow of material into the feed throat of the equipment. On an extruder, you will notice that the drive load will start to decline. For the injection molding process, several air shots can be performed. With engineering plastics, purge out material before shutdown. Purge the barrel with recommended purging material. When it is visible, the melt coming out of the nozzle is finished. Stop the screw rotation and retract the screw minimum equivalent to screw diameter to release the screw tip from melt envelope. The feed throat cooling should remain on. If the shutdown is only for a short period, now the machine can be totally shut down. Common processing problems and remedies. Flash. A thin film of material formed around recesses, along parting lines or sealing faces of the mold known as flash. Remedies. Machine parameters. Increase clamping force. Reduce injection speed or use stepped speed profile. Reduce barrel temperature. Reduce pack or hold pressure and injection pressure. Reduce mold wall temperature. Remedies raw material. Eliminate regrind material. Remedies mold. Correct mold parting line if worn out or damaged. Decrease mold temperature. Short shots. The mold cavity has not been completely filled, mainly at points away from the gate or at thin sections. Remedies machine parameters. Increase injection speed or pack hold pressure. Increase barrel temperature. Increase back pressure. Replace tip seat valve if found worn out. Remedies raw material. Use high MFI grade material. Remedies mold. Increase mold venting. Increase runner or gate cross-sectional area. Increase mold temperature. Increase thickness of thin section. Sink marks. Sink marks are depressions on the molded part in areas of material accumulations. Sink tend to occur mainly on the thickest sections or where there is change in wall thickness. Remedies machine parameters. Increase holding pressure and time. Reduce barrel temperature. Reduce mold temperature. Increase cooling or pause time. Remedies raw material. Check material for moisture. Check dryer for proper working. Use higher melt index if possible. Remedies mold. Increase gate cross section. Increase nozzle orifice. Provide appropriate wall or rib section ratio. Burn spots on surface. Black or dark spots appear on the surface of the molding due to wear, thermal damage or dirt. Remedies machine parameters. Reduce barrel temperature. Reduce screw speed. Decrease injection rate or speed. Unfavorable screw geometry. Clean screw, barrel and tip seat valve. Remedies raw material. Eliminate use of regrind material. Material to be pre-dried, so moisture will be eliminated. Remedies mold. Increase mold venting. Personal safety. Injection molding machine contains many potential hazards. Ensure personal safety while working. Do not climb on the machine. This may result in injury if the person slips or is bumped by the machine. Never remove or bypass the machine's mechanical, electrical or hydraulic safety devices, that is, safety gates, safety guards, safety switches, etc. Do not stand on any part of the machine and reach into the mold area while the machine is operating. Failure to follow these instructions may result in serious personal injury. Neckties, scarves, loose hanging clothing and jewelry such as watches, rings or necklaces must not be worn around moving machinery. Ensure that the electrical power is switched off and hydraulic system is depressurized before starting any maintenance work. Any maintenance work which must be done with electrical power on must only be done by machine manufacturer's representative. Whenever you are working on the injection unit, always wear full face and body protection to protect against the possibility of being burned by hot plastic or gas which could be expelled unexpectedly. Always keep your working area clean. Oil water on the floor may cause someone to fall to the floor, into the machine, or onto another object, resulting in serious personal injury. Preventive maintenance is very important to reduce downtime and to extend life of machinery. Now we will review general preventive checks of injection molding machine. Daily preventive checks. Clean the machine and surrounding area. Maintain voltage fluctuation of the input power. Acceptable range as per IS standard 415 volts AC. Plus or minus 5%. Check proper earthing connections on machines. Ensure the voltage between neutral and earthing. It must be below 1 volt. Perform all the safety checks like ensure operation of emergency push button, front gates and rear guards interlocks for proper operation. Ensure that mounting screws and nuts of limit switches and proxy switches have not loosened and that their parts are functional. Ensure hydraulic gate valve safety. Ensure that clamp should not close with front gate in open condition. Check and clean the mold mounting holes before mold loading and ensure correct size of mounting bolt. Ensure that thread engagement must be minimum 1.5 to 2D. Check and ensure the oil level in the hydraulic reservoir is 3/4 way up the side glass or gauge of tank. Check color of oil visually. It should be yellow. Maintain hydraulic oil temperature 40 degrees centigrade. If the temperature rises above 50 degrees centigrade, shut off the machine and investigate the cause. Inspect the machine for any oil leaks. Correct if found. Check the feed throat temperature of machine. Check lump formation inside feed throat area. If found, use brass rod or aluminum rod to break and remove. Clean the hopper throat cooling lines if required. Check and ensure no material accumulation on nozzle or barrel heater. Check for no leakage between nozzle and sprue bush. Check lubrication pump for proper functioning and ensure all points are lubricated properly. Check and ensure the grease or gear oil in thrust housing of injection unit and replace if dark in color. Weekly preventive checks. Check the attachment of all accessories and auxiliary equipment. All the shielded wires are to be grounded properly. Clean the air filters in the electrical cabinet operator station panel and change if required. If surrounding condition is dusty, clean it on daily basis. Avoid entry of water, dust or iron particles into the electrical cabinet. Do not leave the holes in the electrical cabinet unplugged. Check the thermocouple for any breakage or loosening. Tight and change if required. Don't use the joints for thermocouple wiring. Check injection piston nut for loosening. If found loose, tight same as per procedure of injection nut tightening. Monthly preventive checks. Check the strain rods for scoring and check skate settings. If required, adjust. Do the greasing of platens, skate, injection unit and all applicable locations. Check the fuse blocks to ensure the fuses fit tightly and make good electrical contact with the blocks. Check the motor connection temperature. Excess temperature leads to loose connection. Check the heater bands to ensure that they are tight on the barrel. Make sure the barrel cover is in place over the heater bands to eliminate shock hazards. Check the feed screw mounting bolts are tight. Cooling water quality should be as per recommendation, that is 7.2 to 8 pH, and hardness should be below 500 ppm. Mold care. Please ensure that the selected mold for particular machine is covered 2/3 or 66% area between 4 tie bars. Ensure that mold is mounted on the machine with locating ring of appropriate size. Maintain clearance between locating ring OD and platen ID as per guidelines. Locating ring should not protrude from mold mounting face. Ensure thread size and thread type of the mold mounting bolt. Ensure that mold mounting bolt's thread engagement must be minimum 1.5 to 2D. Too little or too large engagement may pull out the platen threads. Give appropriate torque according to bolt sizes. When molding is completed, ensure to spray rust preventive in the mold to avoid rusting before unloading. After removal of water pipes, drain the water from mold's cooling channels and clean all lines with air to avoid rusting. Advanced injection molding processes. In-mold labeling. The term in-mold labeling is directly derived from the technique. A pre-printed polypropylene label is placed in the mold. This mold has the location for placement of label. Then the molten PP is added to the mold. It fuses with the label and while curing takes the shape of the mold. Result: label and packaging become one. Gas assist injection molding. Gas assist injection molding is a process that produces large plastic parts with complex designs and surface finishes. The process is especially ideal for large handles, equipment covers, doors, bezels, cabinets and skins. Gas assist injection molding is a low pressure process that requires the injection of pressurized nitrogen gas into the interior of a mold. The gas flows through strategically placed gas channels to displace the material in the thick areas of the part by forming hollow sections. The pressurized gas pushes the molten resin tight against the cavity walls until the part solidifies, and the constant, evenly transmitting gas pressure keeps the part from shrinking while also reducing surface blemishes, sink marks, and internal stresses. This process significantly reduces material usage while producing a part with superior structure and aesthetics. Two components injection molding. Bi-injection is the simplest variant of two-component injection molding from a machine and mold point of view. The two colors of the same plastic material are injected into a cavity via two independent gates to meet in the cavity in a more or less defined configuration. When the mold closes, both units start filling the cavity. The position of the borderline between the colors can be defined through different worm speeds. Mucell injection molding. Microcellular injection molding, or Mucell, is an innovative manufacturing technology in which supercritical fluid, or SCF, is dissolved into a polymer melt with a specifically designed screw. During injection, the SCF vaporizes and becomes gas bubbles or foams within molded parts. Because the bubbles can in principle reach micron sizes, the process is known as microcellular foaming. Mucell offers many advantages over conventional injection technologies such as less shrinkage, less weight, low materials cost, and fewer sink marks. In addition, Mucell produced parts show less warping and closer tolerances, and in many cases also cool more quickly.